Hello, this is Sakar here today, and I will be discussing data movement and why it's a problem in chip design and how it may be fixed. Okay, so let's get started with the video. So, first of all, I'll cover what data movement is. So, data movement is just moving data from one location to another. And then the thing to understand is sometimes data is not moved properly. Like it gets, you know, moved to the wrong location, for example, or it gets lost. And, there are errors occasionally in data movement. This can be known as data corruption. Here I have an image showing data corruption and what that is. So now I will be discussing ways to possibly fix this issue. And first of all, why it's an issue, I'll discuss that and dive a little bit deeper into this. So first, why is data movement an issue? So it's an issue because when data is transferred, okay, and say the data doesn't get transferred to where it should be, then the data is lost and there's no more of it. That's why it's a problem. It might not always be restored. And this data movement thing is related to the memory wall. I discussed the memory wall in some of my other videos in the past. So for this video, I'll go over it briefly. So the memory wall is basically, it's this concept within the chip industry that basically says that a chip can cover this much memory basically, and then it keeps on increasing like a function basically, and at one point, once it can't take in more memory, then it stops functioning well basically. So the way these two are connected, data transfer or data movement and the memory wall, is because when the when there's when there isn't enough memory, then in the chip, then data cannot be moved effectively, and then hence data corruption is what the result is. So that's the relationship between the two. So now I'll move on to the possible solutions of this. So one possible solution to this issue would be designing 3D chips or chiplets. So that is basically just vertical stacking. That's what that is. And the reason why that might be better to avoid this these data transfer bottleneck issues and all of that is because new stack chips in a vertical, like structure, what happens is the interconnect lengths are shorter and the bandwidth density increases. When this happens, the data that gets transferred, there tend to be less errors in the data transfer when these circumstances happen. Okay, so that's one solution possible. Another possible solution would be co-packaged optics. So first I'll discuss what co-packaged optics are. So co-packaged optics are just optical engines, and then these engines are put into the chip or chip package. It can be both depending on the specific circumstances. Basically, what these engines do is they also increase bandwidth density. Okay, and then there are these things IOs, which is something that's used within the chip industry basically. And IOs have their limits. They have their electrical limits at what point they can function and when they can't really function effectively, can't really transfer data effectively. But if you used co-packaged optics, because the bandwidth density increases, the IOs can, their electrical limits also increase. So that means more data can be transferred. So that's the good side of that. Those are possible solutions to this issue. So that's pretty much it for this video. I went over the two issues I wanted to go over, and data transfer, data movement. That was the purpose of this video. Okay, and I covered those points. See you in the next video.